have modular code. So I think we did average 3 already. So if you haven't done it, please make sure you do it. I don't think I'm going to go over the exact code for it, but that would be an okay, at least okay function here. But maybe I want a function that just takes average of any array. Maybe I want a function that finds the minimum value. C functions allow me to call a function back over and over and over again. It allows me to break a big, nasty problem into small little chunks and allows me to keep my sanity because there's just too much. If I try to have everything all in one big pile, I'm never going to figure it out. So I want code that I can reuse, call over and over and over again, and that code works as I expect. I don't want to have to, if I need to get the absolute value of something, or I need to get the square root of something, then I need to do this, then I need to do that. I want to separate those ideas out into different functions. Um, I like the fact, and you can call those functions again and again. I like pointing out the fact that we aren't covering it in this degree program, but every computer science school does, or most of them at least, do cover this. The fact of the matter is, a function can call a function itself, actually. Your function can call itself, and that actually allows you to loop around and do the same thing over and over again. So in case you wanted to see what that would look like, there's our dec2bin recursive approach, where I do the same thing as I did before, but instead of doing that multiplier each and every time, I call dec2bin again and slightly modify my inputs. And which will then call dec2bin again, and this my val and multiplier change. And then I go through all this again, and then it goes through it again, and it goes through it again until my val is less than 2, in which case I stop. I can have a function that calls itself until it stops, and that is actually a perfectly legitimate way of programming certain things called recursion, in case you ever see that or anyone talks about recursion. So we have different types of functions, by the way. So a void function is something that doesn't return anything. So the main method can be a void function. Nothing gets returned per se. It just might, it might do a printf statement, for example. And we have other types of functions which return values, like our dec2int, like our average int function, average3 int function that we had. It's returning an integer. It returns some value out to whatever function called it. And we can set variables as well. So that a variable is equal to a non-void function. So I had, what do we call that thing again now? Average 2, I think it was, right? We had the floating point number here is equal to the average 2 function call. So I don't even remember what that syntax was. So we've gone over that example a couple of times where I had a variable and then I have a non-void function. This does something, it returns some value, and then it gets passed and saved off in this variable. The way I like to look at it is if I have a factory making like a car factory, right? A car manufacturer. You have a bunch of parts going into the car, the plant. They make the cars pop out the other end of the factory. If there's no truck to pick up the car and send them down to the dealership, you're just whether you just push them off into the ravine or you're just going to leave them on the side of the road. What are you going to do with those cars? Once you do, your function is done. It passes something up. If you're not using what it passes back, there's something wrong. That function is doing something. You should be catching what it produces and using it. So if I'm calling find the minimum of something, I should be saving that somewhere else after I'm done, right? When the function does something, I should be picking up the work of that function. Okay, so here's an example of foo in action. I might redo this again in a second. So here's my main function. It goes, I get I is equal to 0. J is equal to foo of I, which is actually the value 0. So in this case, the value of n is equal to 0, right? The value of I is equal to 0. So foo of n is equal to 0 in this case. I don't get the variable doesn't get passed. The value of the variable gets passed. N is equal to 0. If n is greater than 0, I will return 1. Otherwise, I return negative 1. Oh, I'm going to return negative 1, it seems. So I return negative 1. I jump back out of my function. So I scoot up here. J is equal to negative 1. That's the whole thing resolves to -1. Bar, I don't know what bar is. It's going to do something. Bar of -1. It'll jump down to that other function, do whatever bar is, jump back again. But notice, when I'm done with foo, I should be storing it, saving it somewhere, or using it somehow. Because why is it doing this work if it's not being used somehow? Just again, to show you this in action, I go to foo, I jump over, go down foo, and then pop back again. So I could define foo if I wanted to. So I might want to define foo here. This function bar, for example, it's taking in nothing whatsoever. It's going to return some integer value. The scanf is going to take some value from the user, some value I from the user. Foo is going to take the character D, whatever that character, literally just the character D. So C, this character C here is equal to the value D here. And let's put, and the value I, whatever the user put in there. And then afterwards, I'm going to do foo, and then I'm going to return I. But foo could be anything. So let's do something with foo. Let's do, notice foo doesn't return anything. So, and I, C, and just because it's a void function, slash N, I, C, and my function, right? It could be something like that. But again, here's what goes in, here's what comes out. This is a function declaration or a prototype. I put that what I'm going to be seeing soon up at the top. This is just a things to come. I'm going to have a function called foo, so that when bar uses foo, it goes, hey, let's look. Oh, well, you have a function called foo. It's up here. Where's that actually defined? Oh, it's defined down here, and it goes down, goes from here, and it just points down to this bottom one. So let me leave you guys with this. I want you to write a function is even. So is even will take in an integer, and it returns 0 if it's false, and 1 if the number is true, if it's true. So if the number is even, like the number 2 is even, 0 is even, by the way, in case you didn't know. If the number is even, it's going to return 1. If it's odd, so not even, 1, 3, 9, then it's going to return 0. So is even, it should return a 1 or a 0, so an integer, and it takes in an integer. I want you to try and write that function, and what the heck, test that function as well. I'm going to open up a quiz for you guys, and it's going to be related to this particular exercise. So try the exercise first, and then try your hand at the quiz. And when we come back next time around, we're going to look at scope, which is again what that bolt is broken, that concept of where variables are declared and how you know which one you're looking at. And then after that, we're going to look at libraries a bit more. Okay? Thank you very much, and try this exercise. Try is even. Make sure you can do it. All right. Thanks, everyone.